I've tried, anyway, I should introduce myself. I'm Bruce Ashfield, AMD, well, Xilinx AMD. I've tried to give this talk several times and failed in different versions to give this talk, so I'm glad to be here and actually give it in person this time. I maintain the meta-virtualization layer as well as the core kernel stuff in OE core. I'll be talking about that later. So I've never been through, even though the presentation existed in various forms for about 2 years, I've never actually given it or walked through it. So I will talk until they throw something at me, or I'm done early because of the aforementioned double espressos that I had. So the topic of this one is I've done various, and I reference them in here, I've done various container talks and binary distribution talks and different parts of this. I've done presentations on different components of the system. But this time I'm going to focus on containers that you don't have to build from source in meta-virtualization every time as a goal. So I'm going to go over a problem statement, say why we think this is useful, or I guess that's more of a royal we, why I think it's important. Level set on containers within the project. I almost always do that. You'll probably recognize those slides when I go through them. Some use cases, talk about what I mean by source versus binary containers, and then some requirements, and then a roadmap. So it's not going to be a detailed, I've done demos at the last virtual ELC. I've done different bits that you can find. So I won't be going over in detail how you compose and build a container. I have other talks that I've done that. And this is sort of where we are, what we can currently do, and where we'd like to go with some of the container construction mechanisms. So, why? What's the problem? I see my problem with not mirroring the display now. I'm going to be... I wonder if I can change that quickly. Never mind. I'm going to lean awkwardly and remind myself what's on each of these slides. So the question is, how do I define a binary container in this? Because obviously, whether you built it from source or not, you're not running a source container on your target. So they're all binary when you run them. So this is no different at runtime on your target than one that came from you building it source. So, for the purpose of this talk, I would say a binary container is an OCI compatible container that is composed and extended without the developer needing to build from source. So you can work with it, you can update it, you can deploy it, and you don't actually potentially even know that BitBake and OE Core and some sort of distro was backing that source. So that is the definition. So it's almost like in that sense, that's what I mean by binary container. So the problem is that, yes, we've had container support for over a decade now within the project. And over those 10 years that I've been maintaining meta-virtualization working containers, sort of the runtimes, the frameworks, deployment, they've all evolved quite a bit. But there's been relatively little has changed in how we build, create, and deploy containers. And if you go search online to try to figure out how to do something with containers, most everything you read does not apply to your Yocto project created container, and that's a little bit disappointing because the first thing they're going to do is tell you, well, take this Docker file or whatever pod man's using and say base container this, base Alpine, base Debian, base whatever, and it goes and it fetches the package feed and creates a container and composes your container and you deploy it. Well, you can't do any of that if you're trying to deploy a container with the Yocto project. So that is where these sort of binary containers come in, because what we have to do is not as easy because you have to have your own container registry somewhere. You might push it to Docker Hub and you build it from source, and how do you keep the source and where it is, and how do you update the container, and you can't really cross-install it onto your initial image. So people have all these hacks to do for, anyway, so it's sort of the deployment of embedded containers is not always easy, and that's a problem. As I have in red there, the other thing that I've talked about and that I sort of work on is some sort of binary distribution and reference feed. So these containers are very tightly, what I'm talking about, it's very closely related to binary reference feed, whether it be packages or state or something out of the project that you can reuse without seeing the source. So everything that Ross talked about for speeding up your build, state and the hash equivalent server, is also related to this and how you would back these containers and be able to update the support. I really should have mirrored my screen. So the question is, why would we want reference binary containers? It's a little bit about the same thing as the binary distribution in that sense. It provides an on-ramp, if you will, for the more casual or application developer or somebody who is not a systems engineer. If they want to be able to develop against an SDK or an ESDK, then they can do it in a container. And the mind share. So it's again, like I said, because none of those, everybody would go pull in an Alpine-based container when they want a small footprint container. Well, it'd be nice if there was an Yocto project-based, OE core-based, similarly sized small footprint container to, that you could use as a base, and then that would help with the mind share so people would realize that you can do this, and then we can pull them into our ecosystem a little bit more easily without needing to accost them with the learning curve in order to get started. And the other goal is the other thing with them is that we can easily blend the advantages of other parts of our build system, even though you're just consuming a binary or a bit you didn't have to build yourself. The SBOM, reproducibility, licensing, all that stuff is still there, and we can actually deliver it with the container, in the container, with the package feed. It's all still there, and you have an easier path to get back to it. And of course, there is always a path to customization, meaning whatever was used to build that binary output, you can get at the hash equivalency, you can get at the state. And so you have a path to customize it yourself more easily than if you started with, some other distribution's base container. I guess, yeah. And, yeah. So that's what we do. That's the goal of them in the project. You can see what's there. I won't bother attempting to read all of the points. All right, so here's a level set of containers in the ecosystem. You build them out of meta-virtualization, which, meta-virtualization, I always say this, should be meta-virtualization and containers, but that's too long a name for a layer. This is where everything happens around, and you never know. There's maybe some more bits that we can hopefully get into core, depending on where we go with some of the new work. But the big thing is it supports all different types of runtimes and containers. It's not there to crown a chosen container runtime or networking stack or whatever. So they're all there, and it attempts to keep the flexibility to let you choose how you want to compose your container, what bits you want to use, what framework you want to integrate it with. Not a lot has come in recently, so I updated this chart. So this is sort of as the things showed up through time, all the way back to 2012. You would have thought more would have happened between 2020 and 2023, given that we weren't doing much, but no, there hasn't been a whole lot of new things that have arrived recently. But there are some more runtimes and different things I'm looking at being able to integrate shortly. All right. I think I pretty much covered this. I'm going to attempt to shorten the talk versus, this will be in the slides for people to have a reference. So this is the, why would you want to use the Octa project for containers? So. All right, so I'm going to now go over some use cases for why you would want to use binary containers or source containers for that matter. So one of the things that we can do better at, if you base your container solution being built and driven from the Yocto project in OE Core, is that we can do multi-architecture, multi-tuning in a single container more easily. There's some tooling changes that need to happen to be able to do that easily, but that is one of the things in particular where I work. There are x86, ARM, FPGA, and you can do a multi-architecture container that covers all the use cases for what you're deploying, and it's quite it's a more seamless experience for the person that's trying to consume your outputs. The other reason that you might want to use containers based on Open Embedded Yocto is the small or reduced footprint containers, because that's sort of inherent with how the system is composed, where we can do BusyBox and MuselC and different things that will make it quite small by default, and then we can all scale up to a full-size system. You might need to be using containers because you want some level of either isolation or security, more isolation than the security part of it. But that being said, we do support, out of meta-virtualization, we can do VM-separated containers. So if you're, I think the Zen Summit guys are here somewhere, you could do a Zen or a KVM-based backed container quite seamlessly. And so you can get enhanced security as well as the isolation and the management of a container. The other useful thing, and it's something that I've been looking at more, is how use it as a way to deploy your application. That being said, we were talking last night, and most of the frameworks are probably too big for your target, like Kubernetes, K3s, these things that we have in meta-virtualization. You might not be delivering them with that framework, but you can still deliver with Podman or Docker itself your application through a container. And one thing is, AI or carrier board content delivery, meaning you could have a base target that has some sort of reprogrammable engines on it. And it's a nice way to avoid needing to either try to do it through package feeds, or in the base image, you can deliver updates through containers and do it that way. So those are the kind of use cases that drive these sort of things. So I'm now going to talk a little bit about container deployment. The issue, this goes into my very first thing where I said the deployment of embedded containers is not always easy or obvious. There's many different flavors of deployment. There is really no one-size-fits-all mechanism. And being able to support all of the different ways that people may or may not want to deploy a container is sort of the flexibility of it is important. But the big critical thing is to make sure they're Open Container Initiative compatible containers, therefore, and then you can use them on anything. Through the history of meta-virtualization and the container support, I've tried to avoid building when it was just Docker. Tried to avoid, and we were doing runC and OCI compatible containers before they were actually all that popular. And again, I mentioned if you want to see a demo of deployment with Podman, I did a talk at ELCE called Embedded Containers as a Deployment Component via the Yocto project. So, and that one I build and extend a Podman-based container and show how we can update it, run it, and monitor it. So that's a hands-on example if you want to see what I'm talking about, deployment in this sense. Like I said, so deployment can be done now. It's not a problem. It is a problem. So the getting that consistent and reusable base, that's the problem. And getting agreement on what that reusable base looks like, that's the challenge. And that's more actually a social engineering problem than a technical problem. Whose distribution? How is it going to be defined? What do the packages look like? What package configs. These are all problems that you have with a binary reference distribution, and they feed directly into this. So that's what I'm talking about, having that reusable base. That's the challenging part. I guess, I don't know. When I was at the back, I couldn't really see that. I hope that's big enough to see. So this is a diagram that I drew up on how you might build from source right now to build and deploy a container through meta-virtualization in the Octa project. Again, you start from the source. You have all your normal inputs, your layers. You do your build. There's two paths that I've labeled there, A and B, where you're pushing to some sort of artifact server, and then you're pulling it onto the target later. Or in the B path, you're actually trying to bake it into your image, usually through some sort of terrible pseudo-based cross-install mounted container, back-end storage, and it shows up in your image. And then at the same time you're doing your build, you're pushing out your SBOM, your licensing, your shared state, and all of your other information. And that's the whole build side. And then you get to the runtime side, and of course you're using a framework of some sort, Kubernetes, K3S, Podman, and underneath there's an artifact repository that's being updated, and you're doing refreshes of the container on your target. Or if you like to make people take whole new images, maybe they're getting a whole new image, or you're doing an over-the-air update or something to do updates. So, this is when you tell somebody, hey, I just want to put a container on my target and run, then this is what they're faced with to even get started to the point where they said, oh, I'd like to just push an update to the container and have my guys do a Podman pull, get the new content and run it, right? That's all that the application developer might want to see, but they have to deal with all of the build part first. So if you're using, for some people it's simple. That's in the fine print, right? That's actually not even simple for me most of the time. Now, if you were going to do this binary container deployment, so all of that big chunk on the left of the build part of it, that's still there, but it's now just a background thing that you don't have to know about or you don't care about. You just see the assembly of the container using some sort of package feed or other binary outputs, and you don't even actually see the package feed because it's just it's inherit base whatever, and in the background it just happens, and you just worry about the target side, which is it's basically identical, where you're just updating and deploying your containers to the target. So that's the goodness that we would like to get to, that everybody that maybe is a non-embedded engineer is used to. We would like something a little bit more similar to that, where there is a build process, but you don't have to know about it until you need it. How am I doing for time? I have 3 minutes left. I can do it. I talk fast enough as it is. I'm forcing myself to. So, again, I'm going to have to read this one because I wrote it last night. What do we got? This is, so I wanted to go over what's the difference between a source versus a binary container. I think I've pretty much covered this already in my rambling, that the runtime is the same and they're completely compatible. There is no difference when you're looking at them at runtime. They're backed by the identical build infrastructure. And it's just that the build and the source is not at the forefront of these containers. The optimizations can possibly differ between the two because that's part of the social engineering. If we're building a reference binary container, a reference binary feed, it's like what level of optimization of the binary artifacts do we do to make them, the goal is to make them more widely usable versus very finely tuned to your target. So the optimization level of the two might be a little bit different. The assembly of the containers might be different. You might be using a third-party tool, your own tool, versus using what I do in meta-virtualization to create OCI compatible containers. And the path to to customizations is more obvious through source containers because you are literally composing an image just like any other image in the Octa project or whatever, and it just happens to be an OCI output image, and so it's pretty obvious what you would need to change to rebuild your application into the new container. It's a little bit more obvious if you use a source container than maybe a binary container, because you will discover you need a way to build your application, and at that point you might be looking for the source. What this means to support binary reference containers in meta-virtualization, hopefully it means adding as little as possible to meta-virtualization, maybe removing some things if they shuffle to different locations in the ecosystem. It means, again, this is the hard part bit. It's the configuration and the definitions of those base images. What do you want in your base container image? How big is it? What does it have? What's the C library? Do we have different flavors and different things? So you need to, meta-virtualization, at least initially, would be where I try to define, hopefully with lots of input, what we want the base container definition to look like. The installation bits, at least for the initial population of the image and the creation of the container, are in meta-virtualization, and in particular how to do some cross installation of containers, which is still a challenge. To do it without, I've been trying to tear apart libcontainer and the backends to try to figure out how to get our sudo to intercept some of the namespace things so we can cross install without needing root permissions on that, and it's challenging. So if anybody's done that without using sudo, please come find me later and send me the patches, because it's going to be a while before I probably get it working as well. But these changes in meta-virtualization will be useful for both source and binary containers. So nothing in here will exclude one versus the other. So some of the requirements of that I was pulling together when trying to define how to make it look when I was trying to bring the roadmap together was, some of the requirements of binary containers is, I've said this a few times, not everyone needs or frankly wants to ever see the source of the application until they need it. And then we need to have I can say, how many minutes is that? 1 minute? All right, good. Standard assembly mechanisms have to work, meaning it's not custom to our project. You should be able to find a how-to, follow that README, and it'll work. You're just changing it to something that we're producing. We need to it needs to be backed by an upgradable set of packages or binary updates. That's like a line item in my thing, but that's actually a big deal. That's probably as big as, it's bigger than the binary container bits of it. These containers also can run on any host distro, meaning you should be able to test your open embedded based application on your development workstation, because there's no reason why you can't produce this small footprint container that runs anywhere. It's got nothing to do with your target. If it's an application that doesn't need the hardware, and it needs to have input traceability, meaning you can do SBOM and licensing. And there's more. It needs to be a standard Octa project open embedded build, no forks, with a path optimization or customization. The original build needs to be extendable and feed into a container update, and that's where the OE hash equivalents and S8 and everything comes in to rebuild as little as possible. Install containers that they can be done at runtime or on the image. It needs to be able to integrate into a CI/CD workflow, and it's largely indistinguishable from other distros at a high level. And I actually am done. This is the roadmap of sort of the ideas, the needs. So we need reference binary feeds. Again, it's a little item, but this is the tip of the iceberg. That's actually the iceberg. The biggest, that's our biggest challenge. Avoid fragmentation. We need a public container artifacts repository somewhere. We've talked about it off and on, but we've never actually done it. So along with the Octa project S-state and different binary things, I'm saying we need to have a public container or some sort of artifact repository that people can just hook into their build, and it's there. We need to be able to test the binary container assembly and update. Again, that's related to the binary distro things that I look at. And that's what I'm going to do in meta-virtualization to make it happen, hopefully over the next coming months. And that's it.